All right, guys, this is our second to the last class meeting. Next week will be our last class meeting before you take your final exam for the class. And today we are going to go over the user-defined functions. So how you can write your own functions. So far, you've been using built-in MATLAB functions, many trigonometric functions, a square root function, printf statement, input statement. Those are all functions. Those are all codes basically that you are calling and doing some and creating your programs with those codes. Any code that is repeated over and over again, or anything that is repeating over and over again, or you want to use it, reuse it, generally that it is always wise to create a specific code for that function and then just call that, what we call that code when you have to use it. And that is called a function. So basically a function is a code that is written that takes some input variables, do some calculation or do some job, and then return you some output. That's a function. And since functions are used very frequently, instead of writing that code as part of your program, you can just write that code, save it as a function, and then just call the function with your input values to get the output values. So that's what the basic, concept of a function is. And functions are written very frequently in all programming languages. In MATLAB, you can use only one M file to write one function and call one function. So make sure so far you've been using the same program, same M file to do all of your problems. Like I graded, the problem set 1 and all 4 problems, pretty much all of you, except a couple of you did each problem separately, which was fine. But except a couple of students, rest of the students did all the problems in a single M file again, which was perfectly fine. You cannot do that with functions though. The function, when you write a function, it has its own file, M file in MATLAB. If you mix anything with that, the function is not going to run basically. So I'm going to show you that. In other programming languages, like in Python, I'm assuming in C as well, but Python, because I also teach Python, you can write multiple functions in a single file and even call individual functions when you are calling that file. MATLAB, you cannot do that in MATLAB. So make sure when you're writing your functions, your program, the homework exercises that require you to write function, make sure do not save those functions with other programs that you are writing. Create separate files for each function. So that's what we're going to look at first today. The second thing we're going to look at is if-else statement and switch statements. If-else and switch statements, basically, they are programming procedures that are used to do some job based on some condition or relational expressions. We also use relational expression in LabVIEW, which are if A is greater than B or A is less than B, A is equal to B, not equal to B, less or equal, greater or equal. All those are relational expressions. And then we use that in LabVIEW as well. And same we're going to use in MATLAB as well. And those are used generally with the if-else condition. If A is greater than B, do this, else do this. We use that with the switch statement as well, with the while loops as well, which we're going to do next week. So relational expressions are very frequently used in, again, pretty much all the programming languages. So we are going to look at relational expression themselves, or simply, as I said, greater, equal, less, and then you can also have Boolean expression and or, like we used in LabVIEW. So themselves, they're nothing, but they're used with if-else conditions, switch conditions, while loops. So we're going to look at if-else condition, switch condition, not condition, switch routine procedure, if-else routine or procedure. But we are going to start with the user-defined functions first. When I graded assignments, I think pretty much everyone got good grade, full grades, I think, except one student didn't get full grade, but most of you did get full grades. I did observe, since Aiden joined us, Aiden, I observed that your file name, you put down homework one or whatever, and you have a spaces. So remember, file name and variable name. We discussed that during our first lecture. You cannot have special characters, and space is a special character. So you cannot use spaces. You can only use underscore special character. So keep that in mind when you are naming your file. Plus, your file name was not in the required format, which I advise to do your first name underscore last name underscore if it is exercise 1, 2, 3. So ex1, ex2, or if it's just homework, if you're putting everything in one homework, then hw1, hw2, whatever. So make sure, do not that mistake again, please. Okay, so let's go ahead and let's show you how to write a function. So let me go to the notes, and then maybe I can redo an example that I did in notes and show you how to do that. Okay, so user-defined functions. When you're writing a function, your M file, and remember again, each function is written in a separate M file. You cannot combine two functions, or you cannot combine your main code with a function in an M file. When you're writing a function, your program should start with the word function. That should be the first thing in a function file. That tells basically MATLAB that this is a function. And it also tells MATLAB another important thing that I'll show you. Then you have to list all the output variables that you are expecting the function to produce. Let's say function is producing 3 output variables, A, B, and C. Now, these output variables can be scalar, vector, matrices, string. One can be scalar, one can be vector. These are just variables. They can hold any type of data based upon how you are calculating that variable through your program, which is the function. So whatever number of variables you have, if you have a single variable, then you don't have to put squared brackets. But if you have multiple variables that your program is returning, then you have to put those variables in squared brackets. Now, again, this is not a vector or anything. As I said, each variable can be of a specific data type. Each variable can be scalar. One variable can be scalar, 2 can be vector, 1 can be matrix, 1 can be vector, 1 can be scalar. They just represent that there are 3 output variables from this function. Equals. And then you write the name of your function. Name of the function, again, use the same logic that you used for the file name and the variable name. That is, don't use a special character except underscore when you are naming a function. The first letter of the function must be, the first character of the function must be a letter. You can use digits, but they should not be the first character. So let's say if I'm creating a function with my name, Masood underscore Ijaz underscore, let's say 1. So that's my function name. So function is the first word, it is followed by the output variables that your function is supposed to calculate, equal the name of the function that you're gonna use to call this function. Functions are called, they are not executed, as I will show you. They are called. As you're calling like cosine function, when you call it, you don't execute cosine, you just say cosine of 50, and then cosine 50 value comes up. So you're calling the function. And then in parentheses, you put input variables, whatever the input variables you want to pass to this function for whatever calculation you're doing. Let's say my input variables are x and y. Again, they can be vectors, they can be scalars. One can be vector, one can be scalar, one can be matrix, one can be scalar, one can be string, whatever, So not necessarily they need to have the same data type. But there are, let's say, 2 variables that are used in this function. So this is how you start writing a function. Function followed by the output variables equal function name, parentheses, function input variables. Input variables are called input arguments. Output variables are called output arguments of a function. Now, when you save a function, let's say I put control S, when you save a function, observe, it saved the function, it automatically generated the name of the file as the same name as my function name. And that is extremely important. The function in MATLAB must be saved with the same name as the function name. Otherwise, you cannot call the function. So it must be saved with the name Masood_Ijaz_1, which it will automatically suggest. So do not change it. Save it with the same name as the function name, that the name that you're giving to your function, if you want to call the function. Otherwise, the function cannot be called. So I'm going to go ahead and save it. And you can only call the function from the folder if your command prompt is in the same folder where the function is saved. If it is not saved in this command prompt, then you have to change the command prompt to the folder where function is saved, or your function must be saved in the root folder, one of the root folders that initializes when Octave or MATLAB initialize. All right, let's assume that this function that I'm using is going to take two input variables, x and y, and it will calculate three mathematical functions, a, b, and c, or three equations, a, b, and c. And those equations, let's say, can be based on x and y. Now, anything that you are going to write after the first line where the function is as comments, that becomes help of the function. So when you write help and square root, SQRT, then it shows help of the function. Or last week we were looking at the help plot, so it was showing plot, help of all the plot in the plot function. Similarly, if you're writing your own function, anything that you are going to write after the first function line as comments, that is considered as help of your function. So when you write the name of your function, this is going to show up as the help. So let's say if I want to write help of my function, and I can write this function calculates three equations which are function of two variables, x and y. The three equations are as follows. So all this is going to be help of this function. So let's say equation A is 2x plus 3y. Equation B is 5 cosine xy plus 3 sine 5x over y. And let's say equation C is 2 exponent of x times cosine of y. Let's say these are three equations, and you want to calculate the result of these equations based on the input variables x and y, and assign, of course, the results to the output argument a, b, and c. It's very important that you assign the values to the output argument. You don't print the values out. Remember, in a function, you don't print the output variables. You only assign those values and not print it. There are a few things that you don't do in a function. First thing, you do not put clear statement in a function. So make sure you note these things down, and they're given here as well in this highlighted area. You don't put a clear statement in a function, because if you do put a clear statement in a function at the beginning, let's say, then any value of x and y that you are sending to this function to calculate ABC, those values are going to be cleared and you don't have anything when the function is going to start. So you do not put a clear statement in a function. There's a no-no. So make sure never do that. Second thing that you don't do in a function, you don't ask these input variables. You don't ask user to enter the values of these input variables, because these variables are passed through the input argument right here. When you call a function, like you say, I am giving example of cosine or sine because we use them so many times. You say cosine of 2. So that 2 basically, you are sending it to the cosine function to calculate the cosine of 2. You're not asking user enter the value. You can ask user in your program enter the value of the input argument of cosine. That's fine. And then you can use that to call the function cosine. But when you are calling a function, inside the function, you don't ask user enter the value of x or enter the value of y, which are the input variables. So you don't use input command inside the function. You can use it outside the function to ask user to enter the value of the input x and y for this function, but you don't do it inside the function. So the first no is don't use clear statement right here. Do not use any input statement in the function. That's the second no. And the third thing that you don't do in a function is to print out the output values, because output values are assigned, they are not printed out. So please note it down. Do not do these things, because I see every semester students are still doing the same thing, although it is in the notes. And I emphasize on these 3 things every semester, and still some students make these mistakes. So once again, I repeat them. Do not use any clear statement in a function when you're writing a function. Do not use any input statement to ask user to give input for the input arguments, because those argument values are passed to the function. You don't ask user from the function to give those values. And the number 3 thing is do not print out the output values for the function. Those values are just assigned to the output variables a, b, and c through your function. Now to write down this function, it's very easy. It's the same thing as you are writing any expression. So a is equal to 2 times x plus 3 times y. And b is equal to 5 times cosine of x times y plus 3 times sine of 5 times x over y. And then my c is 2 times exponent of x times cosine of y. And that's about it. MATLAB sometimes, not MATLAB, Octave sometimes likes you to end a function with the end statement. You don't really have to do that, but if you do that, that's fine. Fortunately, now it's not suggesting the statement end function. Some of the previous versions of Octave they were inserting a statement end function, which is not recognized in MATLAB. End statement is recognized in MATLAB, not with the function. Function does not require an end, but end function statement is not required in MATLAB. Is not recognized in MATLAB, but somehow Octave was putting end function statement automatically, but now it doesn't do that. So this is the function, as simple as that. Observe the difference between a function and a program. If you're writing a program to do the same thing, all you need is assign the XYZ values or XY values at the beginning of your program, or ask user to give those values, and then write these equation. If you have to use printf statement, you can use printf statement, or you can just not put the semicolon and print out the values. Here, first of all, the function has to start with the word function and all those things. Plus, you're not asking user to give any input. You're not assigning any input either, because when you call the function, then you're going to assign the input values. And third, you are not printing any output values, or you're not removing the semicolon to show those output values, because output values are just assigned back to the output arguments from a function, and that's it. Another important thing, the variables that you're using in function, those are local variables. So these variables only belong to the function. Now, when you're calling a function, you don't have to use the same variables. You can use any variables, whatever variable that you want, or input numbers that you want. For example, again, if you call cosine of 5 is not a variable. In the function, that variable could be any variable that they have used. But if you're doing a is equal to cosine of 5, there's no guarantee that in the function, variable a was used as the output argument. And of course, 5 definitely is not used as the input argument. There was a variable that was used as an input argument. So these variables that you're using in the function, they're local variables. You don't have to worry about them. All you need to know how many output variables are there and how many input variables are there. And then you can use any output variables to hold the values coming from the function, and any input variable to assign the values. Now, you don't run functions, because if you run function, this is what's going to happen. Let me go ahead and run it. And it says that error x undefined near line 6, column 9 from this file. Now, why it is saying that? Because there is no value for x. It is undefined. So you don't run function. What do you have to do? You have to call functions. Let's say if I want to call this function, and I call it as v1, v2, v3, value 1, value 2, value 3 equals Masood underscore Ijaz underscore 1, 3.5, 8.7. Then it's going to call the function with the input values 3.5 and 8.7. 3.5 will be assigned to x in the function. 8.7 will be assigned to y in the function. It's going to calculate a, b, and c, assign those a, b, and c to the output arguments, and then a will be assigned to my variable v1 when I'm calling the function, b will be assigned to my variable v2, and c will be assigned to my variable v3 when I call the function. So observe, if somebody's writing this function, I never saw the function. The only thing I can do is help. I call the help file, and it just shows me that, okay, this function calculates 3 equations, which are a function of 2 variables, shows me the help of the file. And these are the equations that it is calculating. And sometimes you don't really know the help of, like cosine. Yeah, you can find the help of cosine or sine or square root. And it's just going to show you y is equal to square root of x, compute the square root of each element of x. But again, you never, when you're calculating the square root or cosine or sine, you don't care if the output variable is assigned to y, uppercase y, or lowercase y, or any other variable. And likewise, the input variable doesn't have to be uppercase x. So these are local variables. Like I'm assigning these local variables, and you can use any variable when you're calling a function. A function can be called from command window, like this, like I'm calling the function. Or a function can be called from any other program that you're using. That program has to be, of course, saved in the same folder as where the function is saved, or the function has to be in the root folder, or in one of the root folders, basically, that get initialized when you start Octave. So this is how you write function. And again, if this, let's say, this you are using in a code over and over again, then instead of writing this over and over again, the best thing is just write it in terms of a function. And anywhere in your program, you want to calculate the values of a, b, and c based upon 2 inputs, you just call the function and calculate those values. That's about it. And that's the whole purpose of using a function. And if I have to submit this as one of my homework problems, then this is the file I'm going to submit by itself with no other files, no other program in the same M file. The file has to be saved the same name as the function name. All right, so far, any question, guys? Okay. Let me show you some good utilities of the function. I think this is one of your exercises as well. So let me show you that as well. Let me ask you a question first. Let's see. And let me open blank page. Okay. Let's see. And most of you are taking, I'm assuming, either introduction to engineering technology or already have taken introduction to engineering technology, I'm assuming, right? Or any circuit class. You guys have taken any circuit class. I assume IET, the introduction to engineering technology, is the first class most of the students take as the circuit class. So I'm assuming if you either admitted this semester or last semester or any other semester, either you must have already taken that class or you are taking that class this semester. Is there anyone who has not taken IET so far or not taking this semester? I'm assuming Dr. Hall usually teaches that, and some other professor may also be teaching it. Okay, in IET, you guys discussed, of course, and we discussed that in LabVIEW as well, if I remember correctly. And we discussed it last week as well, parallel combination of resistors and series combination of resistors. And how do you find the equivalent of parallel and series combination? Let me ask you a question. Let's say a circuit is given to you. Let's say this is the circuit that is given to you. Let's say there are a bunch of resistors. Let's say R1, R2, R3, R4, R5, R6, R7, and R8. Let's say there are 8 resistors, and I give value to each one of them: 100 ohm, 200 ohm, 500 ohm, 700 ohm, 900 ohm, 1 kilo ohm, 250 ohm, and 300 ohm. Let's say these are values I'm assigning. And I ask you to calculate the equivalent of all these resistors between nodes A and B. So looking into nodes A and B, what will be the equivalent of all these resistors when you combine them in series and parallel combination? So who's going to tell me don't worry about the values. Just tell me how you're going to combine each one of them. Which one appear to be parallel, which one appear to be series? Who's going to tell me that?
You start from the right side.
You start from the very end, yeah?
And those two are in series, but they're in parallel with
All right, give me the name of the resistor, R7, R8. So which one are in series?
R7 and R8 are in series.
So R7 and R8 are series. I'm going to add them together. Okay, next.
And then that's in parallel with R6.
That's in parallel with R6. Okay, what else?
And that's in parallel with R5.
That's in parallel with R5.
Which is in parallel to the sum of R3 and 4.
No. R5, observe R5 is connected between the same nodes and R4 is connected between the same nodes. So R4 is also right. R4 is also parallel with R5. Okay, now, so this is going to be when you reduce all this into one resistor from R4 to R8. That's going to be the result. What's next?
You add R3.
Then you're going to add, so let me put a parenthesis here. Then you're going to add R3 to that. Okay, what else? Next, what is next?
It's in parallel with R2.
That's going to be in parallel with R2. So let's say I put a parenthesis here again, and then say this whole thing is parallel with R2. And then what is the last step?
You add it to R1.
That is correct. So that's going to be in series with R1. So this is R equal. So that is going to be in series with R1. And I'm going to put this here. So multiple parentheses and a square bracket I'm putting. All right. So this is going to be the equivalent resistance of this. Now let me ask you this. If you want to calculate this, of course, remember the parallel equivalent formula is 1 over R1 plus 1 over R2 plus 1 over that, the one that we discussed last week. And series, of course, you just add them together. Our series is R1 plus R2 plus R3. Well, we discussed that last week as well, and most of you should be familiar with this since you have taken your IET class. So this is a prime example of what? Now, adding in series is easy because you're just adding them without making any issue. The issue is when you are calculating the parallel equivalent of resistors. Then you have to do 1 divided by 1 over R1 plus 1 over R2 plus 1 over Rn, and you did a problem that you submitted in today's homework in which you did that, and we discussed how to do that. Now, let's say if you want to create a function that does this thing. Oh, I think. Anyways, if you want to create a function that does this thing, and anytime you have multiple resistors, you enter those resistors as a vector, and the output of that function is the parallel equivalent of the resistors. Then anytime you are solving a circuit like this and trying to find the parallel combination, your life is going to become so much easy because all you have to do is to input all these resistors that are in parallel as a vector, and then it's going to spell out a value which is going to be parallel equivalent. And that's one of the problems that you have to do actually. So I'm just showing you the utility of using functions. So that's let's go. There are a bunch of examples. Of course, make sure you go over the examples because again, I saw at least last week some student did make one student at least made a mistake. But if that student would have done the example before that exercise, then the exercise you should not have made that mistake in the exercise. I'm going to come back to this, but this is exercise that I'm talking about. So this exercise that you are doing for the next homework, you're writing a function, first name underscore last name underscore exercise 15, in which you're asking the user to enter register values as input, as many as the user wants as a vector, and calculating the equivalent of those registers. As you can see, I'm giving you two example sample output. They're not, when I'm putting these values, this is the output. That's just what it means. I mean, you can enter any input registers and it's going to generate an output. Now, how it can help you, let's say when you are taking this class and when you are solving something like this, how it can help you to do it quickly. So let me go ahead and show you how I'm going to do this thing. Let's say, let me just go to the not editor. Let me go, because you have to do the exercise, and this is what. So let me go ahead and CLC. Let's say first, I'm going to go ahead and enter all the register values. So starting with R1. R1 is equal to 100. R2 is equal to 200. R3 is equal to 500. And R4 is 700. And R5 is 900. R6 is 1000. R7 is 250. And R8 is 300. when I teach circuit analysis, if you do take it with me, if I'm teaching it the semester that you're taking, you will see that I always use variables to solve any circuit because and MATLAB. Because with the circuit, the important thing is to analyze the circuit, like you just did, Alex. Like you analyze the circuit, you said, okay, which resistors are in parallel, which are in series, and then we wrote down a general equation in terms of the variables that, okay, we have to solve this equation, irrespective of what values do you have for these. Because the parallel has a specific formula, the series has a specific formula, right? You can just put these values here and you can get parallel equivalent. That's not really, that's nothing, basically. It may take you time to do that, but it's a simple addition, subtraction, division, and whatever, right? But more important thing is to recognize, in this case, which resistors are in series, which are in parallel, to write down the basic equation in terms of the variables, which is this. So now if I'm solving this equation right here, and I already have done this code, which you have to do for next homework, the parallel equivalent code, and I have already, and it's the same code like you did for this week's exercise. The parallel equivalent is the same code. It's not changing. The thing that is changing is, instead of making a program, you're making a function out of it. That's the only thing that is changing. So if I want to do this, I have written this function as RP, parallel equivalent. So if I want to calculate R equivalent, and I have all the resistor values assigned already, this is what I'm going to do. I'm going to start again from the right side. R7 plus R8. So I have R7 plus R8. And this is in parallel with R6, R5, R4. So my parallel equivalent function that you are going to write for this week's homework, I'm calling it RP. And in that, I have one of the resistor that I want to take parallel is R7 plus R8. I don't need this parentheses, by the way. R7 and R8, they are in parallel. R7 plus R8 is in parallel with R6, is in parallel with R5, and is in parallel with R4. So that's going to calculate the parallel equivalent of this thing. So this code is going to calculate that because I have a function RP already done. I'm already saved it in the same library, in the same folder, which is, come on, why? I don't understand why sometimes right here. So this is my RP function that I'm calling right now. I'm not showing you function, of course. You have to do the exercise, but I can call the function without showing you the code, of course. The code is the same that you used for this week's exercise. It's just you have to put that code as a function instead of an exercise. Now let's go back. All right, so this is my parallel equivalent of this. Now I have to add R3 into that. So plus R3. And then I have to take a parallel equivalent of this whole thing with R2. So this is one of my resistor, and the other resistor is R2. And I'm again going to call my parallel function RP. That is going to take the parallel combination of this thing plus this and make parallel combination with R2 with those values. And finally, I'm going to add what? R1 into it plus R1. And my final result is going to come out to be 254.89 resistance value. So that's the power of functions, as you can see. If you don't use function, if you want to do it manually, yes, you can do it. It's going to take you time. It's going to take you time, and you're going to waste time for no reason. Why do I say no reason? Because there is really no skills required to perform this formula. I mean, this is just a formula, a mathematical formula. If you just use calculator, it's just going to take you longer. You can still do it, but that's not a skill. That's a skill maybe for a second grader, but not for you guys. I mean, you guys know how to do right, put values and do the division and all those things. So for me, what is more important is what we did earlier, is to write this equation from the circuit. So we read the circuit correctly, we analyze the circuit correctly, observe which are in parallel, which are in series, and write this correctly. And once you have written this correctly, then you can just go to the MATLAB, Octave MATLAB, and you solve it. And as simple as that. And I advise you to use it. If your professor allows you to use it, if you don't have to show your work, you just have to calculate the resistance value, then you can use MATLAB. If you have to show your work, of course, then you will have to show your work. That's a different story. But if the work, if you don't have to show the work, it's part of a bigger circuit solution, you're applying KVL, KCL, blah, 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 whatever. And this is just one step, then you can just use MATLAB to calculate it. So this is, I'm calling my function RP. This is your function, your first name underscore last name underscore XS15. That's what you're doing in XS15, basically, this exercise. Okay. And again, this exercise, you already did that, but not as a function. So it's not something that you cannot do. Pretty easy and very useful. Keep this exercise with you when you're taking circuit classes, basically. So at least you can check your result. If not, if it is not allowed, if the professor is not allowing you to use it, but it's still, at least you can check your result that if your value that you calculated is correct or incorrect using the program or using the function. I allow my student to use MATLAB even in the exam because, as I said, circuit solution is not an issue. Circuit analysis is where I see most of the students struggle, and that's what you have to be good at, analysis of circuit. Solution is easy. Solution, you can use MATLAB to do linear equation solution and all those things. All right, so everyone understand the concept of functions, or is there any question? Okay, since there is no question, let's go back and see. Let's go back and look at this. Actually, let's go back and look at this exercise first. What is it? Not this exercise. This one. Exercise 15. Okay, let's look at this exercise. Let's discuss this exercise. Create a function that converts a complex number given in Cartesian form into the polar form, that is r theta. So Cartesian form, and let me reopen that. So you have complex plane. Again, we discussed complex numbers. So the root of quadratic equation can be complex as well. You have a complex plane, and so you have 4 quadrants of the complex plane. You have negative real values on the x-axis, positive real values, and then you have imaginary value and negative imaginary value. And any point that you take, that point can be in any of the quadrant 1, 2, 3, and 4, and based on in which quadrant that point is located, your value is going to be x plus jy. X and y both are positive. Here, your value is going to be negative x plus jy because x value is negative, y is positive. Here, your value is going to be negative x, negative jy. Both x and y are negative, and here you're going to have x minus jy. And x and y can be any number. Now, each of this can be either represented in Cartesian form. This is the Cartesian or rectangular form, x plus jy, x minus jy, whatever. Or you can also represent it as polar form. That is length of this line from the origin. So the magnitude of this line and the phase of this line with respect to the positive x-axis. With respect to the x-axis, counterclockwise phase is expressed as positive phase, and clockwise phase is expressed as the negative phase. Now, anyone remember how you calculate the magnitude from Cartesian and phase from Cartesian? That from the geometry, yeah.
So for r, the magnitude is square root of x squared plus y squared.
Very good.
And then theta is tangent inverse of y over x.
Very good. All right. Now with theta, there's a little bit of issue, that is, if you are in the second or third quadrant. Do you remember, Robert, what is the issue if you're in second and third quadrant and if you're using tangent inverse of y over x?
Yeah, there might be undefined.
No, it's not undefined. They're defined.
Yeah. Sorry, can you repeat the question? I'm sorry.
Yeah, so you have r.
Yeah.
And then you have theta. Now, if you use r, is going to be calculated using this, irrespective in which quadrant you have your point. So you put x, either positive or negative, a square of that will be, of course, always positive. But as far as theta is concerned, if you're in the second quadrant, and if you're using arctan y over x, what could be an issue that you can see if you're doing it with your calculator or in MATLAB, whatever?
You might need a phase shift of 180 degrees.
You might, you not might, you will need
you will.
a shift of 180, because what happens is when you take arctan or tangent inverse, it's going to take y, which is, let's say this is -2 plus j5. It's going to take y, which is 5, and you don't use j, you only use the magnitude of the real and imaginary. So 5 over -2. Now in MATLAB, if you do tangent of inverse of 5 over -2, a tan d of course is in degrees, a tan is in radians. So if I do 5 divided by -2, that you can also use your calculator, it's going to give you -68.19 or -68.2. -68.2 is going to be this phase right here, because when you go clockwise, that phase is negative. So that's going to be -68.2. But this is not your phase. This is your phase. So what you have to do, you have to add 180 degrees into this value to get the actual phase in the second quadrant. Now, why does it happen? Because again, in your MATLAB or calculator, they don't care if 5 is negative or 2 is negative. Here, if you're doing 2 minus j5, then tangent inverse of -5 over 2 or tangent inverse of 5 over -2, this result is still going to be a negative value, -2.5. This is -2.5. And this is -2.5. So for your calculator or for MATLAB, it doesn't care. For calculator, it's just -2.5, irrespective if x is positive or x is negative, or y is positive or y is negative. So if you use tangent inverse function, then you will have to add 180 degrees if your point is in the second quadrant. So first, make sure do not close your eyes and blindly believe what your calculator or MATLAB is saying. Observe where the point is located. If you're using this, that is, if you're using this, observe where the point is located, and based on that, make sure that the angle that you're getting satisfies with 90 degrees and 180. If it is between 90 degrees and 180 degrees, it is in the second quadrant. And the only way you're going to do that using this formula is that you're going to add 180 degrees, so that it's going to be subtracted. This angle will be subtracted and only this angle will be left. So that's an issue if you're using arctan, although you have to use arctan, and you can add 180. And likewise, if your point is here, then your angle is going to be this, or your angle is going to be all the way here. Usually, when we are expressing angle, it is between 0 and 80 or 0 and negative 180, whichever is the smaller value we give it between 0 and 180. So if we have to go counterclockwise and it is a smaller value between first quadrant and second quadrant, we express the angle as counterclockwise angle. And if it is in the third and fourth quadrant, then we go clockwise because that angle is smaller as opposed to going counterclockwise. So anyways, so if its point is in the third quadrant, and then you use arctan function, both x and y are negative, what it's going to do is going to make a positive result, and it's going to generate angle in the first quadrant because that's going to be the positive angle. So once again, if you see that your point is in the third quadrant, both x and y are negative, what you will have to do, you have to add negative 180 degrees into that in order to correct the angle, because it's going to give you this angle right here instead of, let's say, this angle. So you will have to add negative 180 degrees. So in the second quadrant, you have to add positive 180 degrees with the arctan. In the third quadrant, you have to add negative 180 degrees with arctan. And if it is in the fourth quadrant, then whatever angle you're getting, that's the correct angle because it's going to be between 0 and negative 90. So that's
Same thing for first quadrant?
no, first quadrant is, yeah, it's the same angle because again, both x and y are positive. So it's going to be between 0 and 90 degrees, whatever. Okay. So first and fourth, you don't have to worry about that when you're using arctan. It's the second and third that you have to add 180 in the second and subtract 180 from the third, or add negative 180 to the third. So the exercise or example is asking you that, and a number is given to you in rectangular form. Where is the exercise? A number is given in the rectangular form, x plus jy. This is x plus jy, and it is asking you to calculate the equivalent r and theta. Now, in this case, I'm not using the tangent and I'm not correcting the angle, because to correct the angle, you have to use if-else condition. If your point is in the second quadrant, then add 180. If the point is in the third quadrant, then subtract 180. So that's coming. That's coming later on today. So what I'm doing here, I'm using a built-in MATLAB function, which is called Cartesian to polar, cart to pole. And how does cart to pole work? Let me show you. A comma B is equal to cart to pole, which is Cartesian to polar or rectangular to polar. It takes angle first in radians and then the magnitude. So let's say your angle is, 40 degrees. So instead of putting 40, you put 40 times pi by 180. Make it radians. And let's say your magnitude, this is a Cartesian to polar. So you're putting x plus jy. So you're putting x and y. So let's say, as we were doing, your x is 2 and your y is, let's say 5. Then it's going to generate A and B, A being the angle of your rectangle, angle of your polar form, and B is the magnitude of the polar form. So if you look at the help of cart to pole, cart to pole is a function from this file, and it's going to generate output variable angle first, theta, and then the magnitude r. And theta is generated in radians, not degrees. So what it generated right now, 1.1903 is the angle corresponding to 2,5, and that is generated in radians, not in degrees. And B is, of course, the magnitude, which would be square root of 2 square plus 5 square. So let me go back, and so if you look at the square root of 2 square plus 5 square, then that's going to be 5.3852, which is the magnitude. And let me convert the angle, or we can just use A tan. And if we do A tan, y over x, y is 5 and x is 2, then that's going to be 1.1903, which is the radian equivalent of the angle. So that's how card-to-pole function works. But card-to-pole also take into consideration where the point is located. So you don't have to change the angle by adding 180 or negative 180. For example, if you're doing negative 2 and 5. So if we do A comma B, card-to-pole, negative 2 and 5. Negative 2 is x, 5 is y. Then it is going to show the angle 1.9513. And if I want to convert that, A times 180 by pi to see if it is in the second quadrant, it's going to show you the angle 111.80, which is the second quadrant. If I calculate A10D, 5 over negative 2, I'm going to get negative 68.199. And to have the correct angle, I'm going to add 180 into that plus answer, and I'm going to get the same 111.80. So card-to-pole function, it calculates, it converts the rectangular form into polar form, and it takes x and y separately as input arguments, not as a rectangular number, a plus jb. And the output is first angle, which is in radians, and second part is your radius or your magnitude. What I'm asking in this example is create a function that converts a complex number in the Cartesian form. So input is given in this form, x plus jy, as a single number. And I want the output to be in this form, r theta. That is r first and theta second. By the way, the MATLAB, you cannot manipulate numbers in the polar form. You cannot add number in the polar form, subtract number in the polar form, because there are two parts of polar number in MATLAB, r and theta. So anytime you're manipulating complex numbers in MATLAB, they have to be in Cartesian form. Anyways, so in this example, as you can see what I'm doing, first, I separated out x and y by using the real function and imaginary function. So real of A is my input, x plus jy, let's say 2 plus j5. Or in MATLAB, you're going to write down 2 plus 5j or 5y, whatever. So I extracted 2, saved it in a variable real underscore A. I extracted 5, saved it in image underscore A. And then I applied card-to-pole function, real and image, so 2, 5, let's say. And it gave me the output, which is first value is the angle in radians and second value is the magnitude. And then I went ahead and I changed the angle into degrees, q times 180 by pi. I don't have to do that. This is redundant. I did not have to do this, because I could just use, instead of w, I could just use r, and it will automatically calculate the rate, the variable, output variable r, because that's the magnitude. But I don't know, why did I do redundant stuff? Anyways, so I changed the value of q from radians to degrees by multiplying it by 180 divided by pi. And now I have both variables that I need to pass to my output, that is r and t. So r is going to take the magnitude and t is going to take your phase in degrees. And this is how I'm writing this function. So whenever I call this function, as you can see here, r comma t rect2pole 5 minus 7i. Rect2pole is the function that I'm using. It's not the same as the MATLAB built-in function. MATLAB built-in function is card2pole. So r comma t rect2pole 5 minus 7i, input is a complex number in rectangular form. And r value is calculated this, and t value is calculated this. This is in degrees. And again, I have help of this function. So this is how this function is written to convert rectangular form into polar form. And again, a function that you can keep with you, because complex numbers are used in every class. And many times you have to go from rectangular form to polar form. And if you have a function like this in MATLAB, then it's much easier to do that. All right, exercise 14 is what you're doing in the exercise. Write a function, your first name underscore last name underscore exercise 14 with input arguments to be magnitude and angle in degrees of a complex number, and output argument to be Cartesian form of the same number. So you're writing a function. Output argument is your complex number. So let's say x. Your function name is, if I'm writing this function, my function name will be Masood underscore Ijaz underscore 14. And my input arguments is r and theta. And theta is in degrees. And what I'm doing here is, from the polar form, I'm calculating the rectangular form. That's what we are doing. Now you can do it multiple ways. One way is very easy. If you have polar form, you have r, you have theta. How are you going to calculate x and y? Who's going to tell me? What will be x?
X is it's the r times sine of your degree.
No, not sine.
Oh, it's cosine.
Like sine of theta.
And then y is sine.
R times sine. So you can calculate x and y using the basic formula. And then you can either use a function which is the complex, x comma y, which can create a complex value x plus yj, or you can simply do x plus j times y, and that will make a complex number. And that will be your output argument, which is this x. I mean, I'm taking it as uppercase x. You can take any value. So that's how you can do this exercise. And or you can use pole to card function instead of card to pole. There's also a function pole to card that you can check the help, and you can use that function as part of your program to convert from polar form to rectangular form, and then again combine the pole to card also gives the output in terms of x and y separately, but you can combine them together and give the output as one complex number in rectangular form. So remember, make sure you look at the sample output. This should be the form of your output. So your output is the output argument is a single argument, and there are two input arguments. So the output argument is a single argument, it's not two arguments. So this is my x, uppercase x, and this is your r, and r magnitude, and this is your theta. And this is just an example. You don't have to put 5 and 63. These are just variables, r and theta. Now, once again, keep this program with you, because this program is going to be very useful when you're manipulating complex numbers in MATLAB. Because if the numbers are given, give me an example. Let's see. All right, so I have pole rec. This is my function, let's say. So let's say you are go back to my blank. Let's say you are adding in MATLAB. Let's say you are adding 2 plus 6y plus 5 angles 70 degrees divided by 2 angle 15 degrees plus 9 plus 5 j5. Let's say you are performing this operation. And as I said in MATLAB, the complex number can only be given in the polar form, cannot be given in the rectangular form. I mean, it can only be given in the rectangular form in order for you to manipulate, not in the polar form. So if you are doing this, and if you have a function like this, pole rec, let's say, Then how you can do this using recpol, sorry, or polar rec, sorry, polar to rectangular. Then how you can do that? Let's see CLC. So let's say your result of this, let's say Q will be equal to 2 plus 6J or 6I plus pole rec 5,70. And this whole thing is divided by pole rec 2, what was that, 15 degrees, 15 plus 9 plus 5i. 9 plus not equal, 9 plus 5i. And that is going to be your result. So if you don't have the pole rec function, let's say, then you will have to first convert this into rectangular form and then put it here. But if you do have a function, you can just call the function. It's going to convert the polar form into rectangular form and substitute it in place of this function. And then it's going to go on and add and subtract or whatever, divide whatever it is. And now if you want to go back to your polar form from your result, then you already have a function r comma t rec pole q, and that's going to give you the rectangular, the magnitude is 15.55 and the phase is 38.50. So I'm just trying to show you the importance of functions in MATLAB. They're very important and they make life very easy. If you get used to using, I advise you to get used to using MATLAB for solution purpose. Of course, MATLAB is not going to give you understanding of something, but it can be used as, so it can give you understanding as well when you're doing simulations and stuff, but that's advanced level. But as far as solving something is concerned, I see students lose a lot of points and a lot of time in solution, which I think is useless, because everything is standard. You're converting this as a standard formula. You're doing something as a standard equation. So why spend time using calculators and put one value at a time and take forever and make mistakes and all those? There's no point of doing that. So in all my classes, I use MATLAB functions and all those things, and that's what you're learning right now. So in advance, when you see me in one of the classes, I will ask you, hey, we did that in software. Do you have that function saved or not? Because we're going to be using it. So make sure you keep these functions with you. All right, guys, let's go back. We can take a break, but let's see what else do we have to do before we take a break. So this is an exercise that you have to do. I discussed this exercise. This is exercise I already discussed with you. And relational expression, as I said, you are equating two things: equal sign, not equal, less than, greater, less or equal, greater or equal. This is what we're going to use. And we're going to use it next in the if statement and in the while statement as well, which we're going to do next week. And in the switch statement as well that we're going to do today. So let's do this. It's 6:42. Let's go ahead and take about a 10-minute break and then start back at, let's say 6:50, less than 10-minute break. Oh, by the way, one more thing. You guys must be receiving the invitation to take the survey for the course, the student feedback on instruction. That survey is very important for me because when I read the response next semester, of course, responses are anonymous. I don't know who's taking the survey. But the feedback that you're giving, not the bubbles that you are filling out, that good, bad, or whatever, that doesn't give me much information. But if you're writing down something that, okay, this thing happened, which was good in the class, that really helped, and this can be improved, then I go with that. Like if a bunch of students are suggesting this should be done, then I basically make it as part of the class for next time I offer the class. So I want you to take that survey, maybe after the class or during the break, whenever, but make sure take survey. We are 8 students, only 6 students showed up today. But if you have not taken that survey, student feedback on instruction, go to your course and you can take that survey in your course. It is in the left-hand column, SFI survey, and you can just take it from there. I believe it should be somewhere here. Student feedback on instruction right here. So make sure you take this survey. And again, it's an anonymous survey. So nobody's going to see this. This is just showing me how many students have taken the survey. Of course, the report is not available until July 31st. But you take that survey, it's an anonymous, no name, nothing, but it helps me and it helps every professor. Whether the professor is doing a good job or a bad job, you have to tell the professor, because this survey is also part of our annual evaluation. Our dean basically used this survey to look at the performance. So if some professor is not doing a good job or anything, basically, if you put that, that is discussed with the dean, that, for as an improvement plan and stuff for professors. So make sure you take this survey for every class, and especially my classes, because I use that survey. All right, let's go and take a break until 6:55 and then start back. All right, guys, let's go ahead and start. I forgot to pause the recording, so it was still recording. That's okay though. Okay, so the next thing we're going to look at are the if statement and the switch statement. And I'm just going to go over my text and just discuss with you about the if statement. So as you can see, the if statement from this piece of code, it's pretty simple. You are doing a comparison with some variable. For example, here I'm asking the user to enter a value for a variable x, and then I'm checking if x is less than 10. So you have the comparative statement over here. If x is less than 10, increase the value of x by 5, plus 5, add 5 in the value. And then evaluate y is equal to x squared. Now, if x is less than 10, then the input value is going to be increased by 5, and then the y value is going to be evaluated. And if x is not less than 10, if it is greater or equal to 10, then this loop is not going to run, or this condition is not going to run, because this is going to be false. So this is going to result in either true or false. It's going to be 1 true if x is less than 10, and it's going to be 0, that is false, if x is greater or equal to 10. So if a statement, basically it looks at if the result is 1 or 0. That is if it's true or false. If true, do whatever is written under the if statement. And if false, then don't do this thing. Come out of the loop. That's what basically if does. So if x is greater or equal to 10, then it's not going to add 5 into x. It's just going to keep the original value. And then y will be evaluated based on the original value x. So that's just a simple example of what if loop, if statement is doing. If a statement has to be end with an end statement. And if you're putting it in the Octave editor or MATLAB editor, then it's going to adjust, of course, the indentation as well by itself. Now, you also have, if you have two conditions, then you use and, you use or, the Boolean function. And many times you have to use two and two or. Because sometimes if you use a single and, it may give you a warning, may not give you an error, but it may give you a warning about, use the double sign or whatever. However, single also works, but it's just a warning that may pop up or a suggestion that may pop up. Observe that when I put a single and, it highlighted it in my editor. So if I put two and, this may not highlight it. But anyways, single and works as well. So here you can see that if x is greater or equal to 0, one statement, and x is less or equal to 10. So this and, I advise you to use two of them so that you don't get any warning, but single and works as well. So now I'm comparing I'm comparing x within a range. That is, x is between 0 and 10, including 0 and 10. So if this statement is true, let's say if x is 5, then this statement will be true. That's going to be 1, true. And if x is 5, then this statement will be true as well. That's going to be 1. So you are using a Boolean AND gate. And for Boolean AND gate, if both inputs are 1, the output is 1. And that's what the result of this comparison is going to be, that it's going to result in a true statement. So if true, add x, add 5 into x, and then evaluate the equation. So this is just to show you that if you have to define a range of values, then you can use and, or you can use or as well, based upon if you just want one of the condition to be true. Because with the or gate, with the or Boolean gate, if any of the condition is true, then the output is 1. And it's only going to be 0 or false if both conditions are false. So yes, go ahead. Question? Did someone have a question? No?
No, back up.
All right, guys, if you don't have any question, and if there's a
Fine.
people talking in the background, then just mute yourself. Okay. Now, if you also have multiple two conditions, that if this is true, do this, or do this. If it is not true, then you can use if-else statement. If x is greater or equal to 0 and x is less than 10, so if the range of x is between 0 and 10, then evaluate y according to this equation. Else, if this statement is not true, that is, if it is outside this range, then evaluate y according to this equation. So this is if-else statement. If the condition is true, then do this. If the condition is false, that is else, do this. So it's going to do one condition for true and the other condition for false, whichever is going to be met, whichever condition is going to be met, that is going to be executed. Either the if or else, one of them will be executed. Both are never going to be executed. So that's if-else statement. And then you can have multiple if-else statement, which are called if-else-if. That is, if you have multiple conditions. So if your range of x is greater or equal to 0 and x is less than 10. So if your range is between 0 and 10, including 0 but excluding 10, then evaluate y according to this equation. And of course, x is entered by the user. Else if x is greater or equal to 10, but it is less than 20. So if the range is between 10 and 20, excluding 20, then evaluate y according to this equation. Else, if the range is between 20 and 30, including both 20 and 30, x 20, then evaluate y according to this equation. And if nothing is true, if x is outside all three ranges, then assign 0 to y. So this is if-else-if statement. And this is how you do if-else-if. As example 16, I want you to go over it. It's just, evaluating different equations basically based on the value of a. A is the variable here. So similar to what I'm showing you here, instead I'm using the variable a. All right, exercise 16. Again, similar exercise that you submitted today about the resistors. But in this case, you are checking if the resistor value is negative or not. So you're going to ask user to enter resistor values as a vector. And if any of the value that user is entering is negative, any one value, then you are going to say, you're going to print the values of resistors cannot be negative. And then end the program basically. But if all the values are positive, then you are going to add up all the values to find the series equivalent, and then apply the formula for parallel to get the parallel equivalent, and then print out those values of series and parallel. So this is a sample output. Enter resistor values as a vector. So I enter a few values as vector, and then it calculated the series and parallel because none of the value was negative. And then I enter again as a vector, but I chose one value to be negative. So it is going to tell me resistors cannot be negative and come out of the program. So I'm using if-else condition over here. If-else condition, and I'm checking if any value is negative, do not do any calculation. If all the values are positive, then do the calculation of series and parallel. So I'm using if-else condition, and that's what you have to use, if-else condition. Some of the functions that can be used are, of course, sum function, as we discussed, to sum up the series and all this. There's a function called find function. what find function does is it finds, let me show you. So let's say R is 1, 2, 3, 4, 5, -7, -8, 9. And if I do find R less than 0, then it is going to show me the index. If any value is less than 0, it is going to show me the index of those values. So you can use find function actually to find if any value is less than 0 or not. Or even you can do 0 less or equal to 0 to figure out if any value is less or equal to 0. Because even if your value is 0, you cannot calculate the parallel equivalent of that, because you're doing 1 over 0 does not exist. It's not a number. So you can use the find function to see if any value of the input vector that user is giving is negative. And if it is, then of course you can just print out that registers cannot be negative. If not, then you can add them to calculate the series equivalent and then perform the parallel equivalent formula like we discussed last week, and then print out the values. So that's one way to do it, to use find function. There can be other functions that you can use, comparative functions. Exercise 17 is another exercise. I think all these exercises you have to do next week. Exercise 17 is another exercise. You are writing a function, your first name, last name, to convert the complex number from rectangular form to polar form. Again, so this is rectangular to polar, but in this one, you have one input argument, which is the rectangular number, and two output arguments, which is magnitude and degrees, magnitude and phase and degrees. Now, this is similar to the example I'm assuming, right? Example 15. This is similar to example 15. Your input is a rectangular number, your output is R and T, but there's a catch over here, and that catch is that you're not using any built-in function, but you have to use the tangent inverse of y over x and square root of x squared plus y squared. You must use the basic mathematical conversion equations to convert the number from its rectangular form to polar form, and must use if-else condition to determine the correct angle with the inverse tangent function. So what we discussed earlier, if the number is in the second quadrant or third quadrant, then you have to add 180 degrees or subtract 180 degrees. That's the main idea in this problem, that you're writing a code and you have to use if-else condition or if condition and check if your number is in the second quadrant, then your angle that you're calculating using the A tan function, A tan-D function, add 180 degrees in that angle. And if the angle or if the number is in the third quadrant, then subtract 180 degrees to get the correct angle. So again, this program is not a function. When you're not sorry, it is a function. You're writing a function, but in this function, you're not using any built-in card to pole like we did earlier, but you are using the basic formulas, that is x squared plus y squared, which will be the radius or magnitude, and angle will be arctan of y over x, or imaginary over real of the number, whatever the number input number is. And use if-else condition or if condition to determine in which quadrant it is present, and based on that do that. You may have to use two if conditions. If the number is in second quadrant, then add 180 degrees. Then theta is going to be 180 degrees plus A tan of y over x. And the second if condition will be if the number is in the third quadrant, then negative 180 plus A tan y over x. So you may have to use two if conditions here. There is no else condition that you have to use, but just two if conditions, and end each if condition with the end statement. And if the number is in the first and fourth quadrant, then of course you don't have to use if condition. Or you can use else basically. Or you can use if else if actually. You can use if the number in the second quadrant, add 180 into the phase. If it's in the third quadrant, subtract 180 from the phase. Else, either fourth or first, that's the else. Don't do anything, just whatever phase you're calculating using 8n, that's going to be the n. And of course, outside the if else statement, you can calculate the magnitude, because magnitude is not going to change irrespective where the number is located. So this is an exercise, same exercise like example 15 or whatever, but you have to use the basic formulas and you have to use the if else condition to do this problem.
I had a question.
Go ahead.
Is it giving the output in radians, or is it giving it in degrees?
Degrees.
It is giving it in degrees. Okay, just making sure. I thought we had to do a conversion.
Not given. You have to give the output in degrees, because the output is r theta. Input is your number, x plus jy.
Right.
Output is r and theta. So you have to give the output in degrees.
Okay.
You have to calculate the output in degrees, basically.
Okay.
8 and d, use 8 and d instead of 8 and. As I showed you, 8 and d calculate tangent inverse in degrees. But the main thing here is to use if-else condition to locate where the point is located, in the second quadrant, third quadrant, or in the first and fourth quadrant. All right, the last thing we're going to discuss is the switch statement, which is very close to if statement. But sometimes it's much easier to use switch statement if you are choosing one of the, let's say, one of the method to do something, let's say, or choosing one of the values to do something, and the expression may have multiple values. This is the syntax of switch statement. Switch expression. Whatever expression is either holding a value or a string. So let's say if I do switch name. So if I'm asking user to enter their name, input, enter your name, whatever, then I'm looking at what name was entered. That's my expression, let's say. And case expression value 1. Let's say the first name or the user is entering the name Mike. So if the value of the expression is Mike, then do these things. Let's say the user is entering the name Joe. If the value of the expression is Joe, then do these things. So, keep on going until you find that whatever was the expression value, user did not enter that value. Then you say otherwise, whatever operation you want to carry it out, if none of the expression value is met. So it's similar to if-else condition. If expression comparison do this, else, if else do this, if else do this, else do this. So it's close to that, but it's a different procedure. Switch and case statement. Let's look at this example, for example. Display the average score of the term or the final exam. So you have a term exam and you have a final exam. For MATLAB class based on user's inquiry, assume that the term exam average is 75.4 out of 85 or 88.7%, and the final exam average is 70 out of 85 or 79.5%. So if you look at the code, let me increase it. If you look at the code, I'm asking, input, please select the exam for which you want to check the score, midterm or final. And I'm getting that in the variable exam. And remember, if you are taking input of any string, then make sure I'm not putting, colon S over here. So I will have to enter it as in quotes. But if you don't want user to enter inside quotes, then make sure you put colon S over here, as we discussed last week. Otherwise, user will have to enter in quotes to select either it's the midterm exam or final exam. Now, if the case, so I'm doing switch exam. Now, observe this lower. There are two functions. One is lower, one is upper. Let me show you what lower and upper does. So let's say if I write my name and assign it to a variable q. If I do lower q, then it will convert all the letters into lowercase. And if I do upper q, it converts all the letters in the uppercase. That's what lower and upper does. Now here in this program, I'm doing lower of exam. Exam, of course, is the variable in which I'm holding midterm or final as entered by the user. Now, why I'm doing lower? Because I don't know how the user must have entered midterm and final. User might say midterm, or user might say final, or user might say final, whatever. This switch, the case statement must exactly match one of the strings that user is entering. So if I don't know how the user must have entered that combination of characters, midterm or final, what I'm doing is I'm just from my side, I'm making a lower case of what user is entering by using the lower function. So switch lower exam. And then I know for sure that all the letters in the midterm word must be lowercase. So I went ahead and then I created a case midterm with all the lowercase letters. And then I printed out midterm average was this and blah, blah, blah. And then I created another case final, again, lowercase, because I'm lowering down the exam variable. And then I printed out again, final score was this. Otherwise, if I did not get midterm or final, then your selection was invalid. If you look at the execution, please select the exam for which you want to check the score. And I chose midterm. And again, observe midterm is in quotes because I did not use quotes or quotes S inside the input statement. Midterm average score was this and blah, blah, blah. Example 17 again, choose midterm or final. I chose final. And it shows the final scores. And select midterm or final. And I chose exam 1. Then it says your selection is invalid, which is under the otherwise. And here's the explanation for lower as well. So lower and upper, you should use it, whatever you want to use. Because again, when you're using switch statement, you have to match exactly what is written under case. This variable should match exactly with that in order for you to run whatever is written under that case. You can have multiple strings as well. I think the next one is multiple string example. So you can have multiple strings, for example, if the user entered midterm or exam 1, then you can also do that in the braces. You can choose multiple strings, whatever user you think user is going to enter, either midterm or exam 1, or if you're giving choice to the user, either you can enter midterm or the one or exam 1. Then you can choose both as your case, and anyone is selected, anyone is entered by the user will make the case for this. You can also use numbers. So you don't have to use characters. You can do 1, 2. So if the value of exam is 1, then it's going to do this. If the value of exam is 2, it's going to do the same. If the value of exam, let's say, is 3, and it's going to do the final. So you can also use numbers. You don't have to use characters, by the way. Example 19, this is something what we discussed in Cramer's rule and matrix inversion method and Cramer's rule to solve the linear equations. So in this case, I think we discussed that in detail in LabVIEW, if I remember correctly. In this case, I'm solving the set of linear equations, and I can solve it using the matrix inversion method, or I can solve it using Cramer's rule. So I'm asking user select the method you would like to use to solve the linear equation. This is the equation that we are solving. These are the equations. And I'm asking user to enter 1 for Cramer's rule and 2 for matrix inversion. And the value is saved in the variable method. So switch method, case 1 is for Cramer's rule. So I solve x and y based on the Cramer's rule. That's determinant of, I think we discussed that. I'm not going to go into Cramer's rule at this time though. And then case 2, which is the matrix inversion, then I solved it using the matrix inversion method that you guys also did last week and submitted your homework based on that. Otherwise, your selection is invalid. So here I'm giving an example that you don't have to use strings for the cases. You can use numbers as well, simple numbers, 1, 2, 3, 4. And I believe this must be the last problem for next week, 18, yeah, 14, 15, 16, 17, and 18. All right, and this one, I want you to understand it very clearly because students make a lot of mistakes in this problem. This problem is based on the switch and case, basically. So make sure you use switch and case, what we're discussing. Do not use if, because this can be done with if, but I want you to use switch and case. All right, so what's going on in this problem is many of you may be taking signal processing with me in the future, digital signal processing. And in digital signal processing, there are functions, what we call window functions, that we use to perform, to smooth out the input data so that we can see its spectrum clearly. Okay, the theory we're going to discuss in DSP. So don't worry about the theory. Understand what you're doing in this problem. So the first thing that you're doing in this problem is you are asking user to enter some input data. That's the first thing in this problem. So let's say if I write down X input, and in the parentheses, in the quotes, I write down enter an input data vector. That's it. Enter an input data vector. Now, the user can enter an input data vector whichever way the user wants. That is, if I'm the user, I can do 1, 2, 3, 4, 5. That's the data vector. I can do cosine of 2 times pi, 0 to 12, 0 to 0.01, 12. This is a data vector that is going to calculate different values of cosine, 2 pi, then 2 pi times 0.1, 2 pi times 0.2, all the way up to 2 pi times 12. That a data vector can be generated like this. A data vector can be generated as 0, 0.1, 12. That's a data vector. So you are asking the user to enter a data vector, irrespective of how the user is going to enter it. That's not your headache. So your question is enter the data vector, and that data vector is saved in the variable X. Now, the length of the data vector that user has entered, you can find that length using the length function, length of X. And this length of X you are assigning variable N, uppercase N. which is the length of the input data vector. And then you also have lowercase n, which basically is going from 0 to n minus 1. So that's a vector that goes from 0 to n minus 1, uppercase n minus 1. So let's say the length of x in this case is 5, because you have 5 values here. So n in this case is going to be 5 for the first case. So the lowercase n is going to go from 0 to 4, 0, 1, 2, 3, 4. Any question about so far what I've explained? I want you to understand clearly what is x, input, what is uppercase n, and what is lowercase n. And x can be any variable you can take, but lowercase n and uppercase n are the variables that are used in these equations. So I want you to understand them very clearly. Uppercase n is the length of the input data vector, and lowercase n is a vector that goes from 0 to uppercase n minus 1. Any question about these variables? Okay, I assume they're clear. We're going to ask user the second question, and that second question is, which window function out of these three does the user want to use to smooth the input data? That is, smooth the values of x. We have three functions: triangular, Hamming, and Henning. And these are the equation for each function that you're going to be using to generate a vector that will have the same length as the input data vector. Why it will have the same length as the input data vector? Because they are function of lowercase n. And lowercase n is the vector that goes from the first value, or that goes from the over the length of the input data vector. And you also have uppercase n here, which is the total length of the input data vector, which is a single value. And lowercase n is a vector. So this is vector, and uppercase n is a scalar. So you're going to ask the user, choose one of the functions, triangular, Hamming, or Henning, to smooth out the input data vector. Let's say the user chooses Hamming. And you can ask user to choose Hamming as a string, or you can ask the user choose press 2 for Hamming, press 1 for triangle, press 3 for Henning, whatever you want to use. I'm not restricting you to ask user whichever way you want the user to ask. Once you have these two items, once you have the input data vector, and once you have the data vector generated from the window function that is chosen by the user, and data vector will be generated in accordance with the equation that is given for each of these. And you're going to choose only one, whichever user is choosing, Henning, Hamming, or triangle. And you're going to generate the vector according to that window function. Let's say for Hamming, or for Henning, this will be the equation that you're going to use to generate a vector which will be the same length as x, but different values, of course, according to the window function. Once you have these two items, that is input data vector, the data vector generated from the window function that user is going to choose, and lowercase n, then what you're going to do, you're going to do subplots. In the top subplot, you're gonna plot the input data vector versus lowercase n. And in the bottom plot, you're gonna plot the window treated data vector versus n. What is window treated signal? Window treated signal is nothing but your input data vector times the window function. And of course, these two are vectors, so you're going to put a period. That's what your window treated data vector. That is, you're going to take the input data vector and multiply it by one of the window function, whichever window function the user is asking you to, the user is choosing. So when you multiply them together using array-wise multiplication, the result that you're going to get is another vector, and that vector is the window treated signal. And that signal is going to be plotted in the second subplot. So that's this problem, and you're using switch to work on this exercise. So switch you're going to ask the user to choose a window function, and that is going to go through switch statement. Switch, triangular, switch, Hamming, switch, Hanning, or switch 1, switch 2, switch 3, whichever way user is entering it based upon your directions. So switch statement basically is used to switch one of these functions. And then you're, as I said, you're going to create a window treated signal and then plot the original signal versus lowercase n, and window treated signal versus lowercase n. Again, lowercase n is a vector over the length of the input data. So if input data has 5 elements, lowercase n is going to be 0, 1, 2, 3, 4. If input data has 120 elements, then it's going to go from 0 to 119. 0 to uppercase n minus 1. This is what you are doing in this exercise 18. And again, it's important to understand different variables, because many times students make mistake. They choose uppercase n to be the input data vector. They're all confused basically. But remember, uppercase n is the length of the input data vector, not the data vector itself. Uppercase n is the length of the input data vector, which is also given right over here. Length of the vector. And lowercase n is 0, 1, 2, 3, all the way up to n minus 1. Any question about this? Anything that is not clear? Of course, this recording is going on, so you can revisit it. But make sure, do not make mistake in this, because every semester I explain it in detail, and every semester some people are making mistake in this problem by taking different variables that they're not supposed to be. Everyone is clear with uppercase, what is uppercase n, what is lowercase n? Of course, x is the input vector. Let's say x, I'm calling it x, you can call it anything. Okay, I assume that you guys understood this. So this will be the last exercise for next week. And next week, of course, is our last class meeting. And we're going to finish basically MATLAB portion, whatever is left. These are some of the sample runs from my program. So you can look at how I'm entering the data and how the output looks like. All right, guys, with that, we are done. So only 6 of you showed up today. Samir is not here. I can see that. Who else is not here? Samir is not here. And let me open my software. Okay, Simon is not here and Donald is not here, right? Donald is not here. Yeah, Simon and Donald are absent. Okay, guys, any question that you have that I can answer before we end our meeting? No? Okay, make sure to take the survey. Again, if you have not taken it, make sure to take the survey, and I will see you guys next week.
Thank you, Professor.
Have a good evening. Bye.